Good morning, dear students, and welcome back. As we discussed about the molecules, particularly molecules of elements, we also do have molecules of compounds. The molecules of a compound are formed when atoms of different elements combine chemically in definite proportions. For example, the molecule of carbon dioxide consists of one carbon atom and two oxygen atoms. Therefore, the ratio by mass of atoms present in the molecule of carbon dioxide is the mass of carbon ratio the mass of oxygen is equals to 1 ratio 2. This means that the ratio by mass of atoms present in the molecule of carbon dioxide is 3 ratio 8, where 12U and 16U are the atomic masses of carbon and oxygen respectively. Atoms of different elements join together in definite proportions to form molecules of compounds. A molecule of calcium, when combines with a molecule of oxygen, forms calcium oxide. Atomicity is 2, as two atoms are present in a molecule, and this is the example of diatomic molecule. Two atoms of hydrogen when combines with one atom of oxygen, it makes a molecule of water. Atomicity 3, triatomic molecule. One nitrogen atom and three atoms of hydrogen combines in a chemical way to form a molecule of ammonia. Atomicity 4, and it is the example of tetraatomic molecule. Two atoms of potassium, one atom of sulfur, four atoms of oxygen form potassium sulfate. Atomicity 2 plus 1 plus 4, that is 7. And it is the example of heptaatomic molecule. Tri, tetra, hepta, all are the examples included in polyatomic molecules of compounds. The chemical formula of a compound, thus, is a statement of its composition in which the chemical symbols tell us which elements are present, and the subscript or lower figures tell us how many atoms of each element are present in one molecule of the compound. It represents the name of the compound. It also represents one mole of molecule of the compound. It represents a definite mass of the substance equal to the molecular mass expressed in grams. So if we consider the chemical compound calcium carbonate, the chemical formula or molecular formula of the compound is CaCO3. The statement gives us the composition in which chemical symbols Ca, C, C and O3 tells us that elements present here in the compound are calcium, carbon and oxygen respectively. CaCO3, the subscript or the lower figure 3 tells us that one carbon atom, one calcium atom, but three atoms of oxygen are present in one molecule of the compound calcium carbonate. Similarly, if we'll see the following compounds: magnesium chloride, MgCl2. The chemical formula helps us to know that an atom of magnesium and two atoms of chlorine are in a molecule of the compound calcium oxide CaO. An atom of calcium and oxygen respectively form the molecule of the compound when bonded chemically. Copper nitrate CuNO3. One atom of copper, one atom of nitrogen, three atoms of oxygen chemically bonded to form copper nitrate. Aluminium chloride, an atom of aluminium and three atoms of chlorine combine chemically to form a molecule of aluminium chloride. If we consider the total number of atoms in a molecule, it is atomicity. So atomicity of magnesium chloride will be 3, of calcium oxide 2, of copper nitrate 5, of aluminium chloride 4, and of calcium carbonate 5. Has one atom of calcium, one atom of carbon, and three oxygen atoms are bonded chemically to form calcium carbonate molecule. Similarly, of these, the name of the compounds and the chemical formula of the compounds are given here in the tabular form. Potassium sulfate, K2SO4, sodium sulfate, Na2SO4, calcium sulfate, CaSO4, magnesium sulfate, MgSO4, copper sulfate, CuSO4, sodium chloride, NaCl, sodium nitrate, NaNO3, sodium carbonate, Na2CO3, ammonium chloride, NH4Cl. These are the compounds in the solid state and are salts. Definitely are not used for the purpose of food preparation as table salt except sodium chloride, but are used in different ways. Just as an atom has atomic mass, in the same way a molecule has a molecular mass. The molecular mass of a substance is the relative mass of its molecule as compared with the mass of a carbon-12 atom taken as 12 units. The molecular mass of a substance, particularly of a compound, therefore is the mass in the atomic mass units, AMU, of all the atoms in the given molecule. It is more commonly referred to as molecular weight and abbreviated as MW. An atomic mass unit is defined as 1/12 the mass of carbon-12 isotope. As we had already discussed, the old symbol was AMU, while now we are using only U as unified unit for atomic mass. Carbon-12 is defined as weighing exactly 12 U per atom. And as the molecular mass is sum of atomic mass of atoms present in a molecule, therefore the unit of molecular mass also is either EMU or U. Let us see a few examples. When we consider molecular mass or molecular weight, it is the sum of the atomic masses of all the atoms in a molecule, whether similar or dissimilar. So if we consider chloroform or chloromethane, trichloromethane, we can say that its molecular mass is equals to 12 U or 12.01 AMU plus 1 U or 1.008 AMU plus 3 times the atomic mass of chlorine, that is 3 into 35.5 or 35.45 AMU. So altogether, after the calculation or arithmetic operation, the mass of trichloromethane is 119.37 am, rounding to 2 places after decimal point. Similarly, molecular mass of ammonium carbonate. We can say that Since nitrogen and four atoms of hydrogen are in twice, so we consider atomic mass of nitrogen as 14U or 14.01 AMU, and four times the atomic mass of hydrogen, that is 4 into 1.008, 1 U the mass, multiplied by 2 plus atomic mass of one carbon atom present in the compound, 12U, and 3 times as 3 atoms of oxygen are present in the compound, 3 into 16 AMU. And after the calculation, we can have the molecular mass of ammonium carbonate as 96U or 96.09 AMU. So today we discussed molecules, molecules of elements, molecules of compounds, and the sum of atomic masses of all the atoms present in a molecule as molecular mass or molecular weight. In our next class, we will start with ions.